So I'm going to cover the rational root theorem. So it's saying that if I need to figure out how to factor this, I need to know where to start. And to get a starting point, we're going to look at possible roots. And possible roots could be a factor of the constant term, we're going to call this one p, over a factor of the leading coefficient, which in this problem, example 3 from your book on page 191, is 1. And we're going to call that q. Okay, so let's write down all the factors of the constant, which is 20. So I'm going to write them as pairs because it makes it a little bit easier. So 1 and 20, 2 and 10, 4 and 5. It's also always going to be the positive and the negative. Now, luckily, the leading coefficient here is 1. So it's going to be over, there's only one factor, 1, and then each of these are plus and minus. Okay, so that means that all of these, positive negative 1, positive negative 2, positive negative 4, positive negative 5, positive negative 10, positive negative 20 could be a possible root for this polynomial. And there's no other easier way to do this than just to dive in. Okay, so I'm going to use positive 1, and I'm going to use synthetic division. I'm just going to move it along quicker. So I'm going to use 1, negative 8, 11, and 20. Okay, drop it. Multiply, add, multiply, add, multiply. Oh, notice this last term is not 0. If this last term is not 0, that means that positive 1 cannot be a possible root. Alright, next one. I'm going to do negative 1. 1, negative 8, 11, and 20. Okay. Drop it, multiply, add, multiply, add, multiply. Oh, look, this comes out to be 0. If, when doing synthetic division, the last term turns out to be 0, you know that this is one possible root. So awesome. That's where we start. Now remember, when you put it in parentheses, it has to be the opposite. So that means one factor here is going to be x plus 1. Perfect. Now look how synthetic division helps you with a polynomial. I'm going to write the rest of my polynomial, but instead of being x cubed, I'm going to take it down 1, so it's going to be x squared minus 9x plus 20. Now, thank goodness, this I know I can actually factor that one. So 20 and negative 9 is negative 4 and negative 5. Perfect. So it's x plus 1, double bubble, x minus 4 and x minus 5. So now I was able to fully factor this complicated polynomial by using the rational root theorem and guessing what some of my possible roots are. Okay, so I'm going to do an IXL problem that somebody got wrong, and it said that it had a leading coefficient of negative 12, so that's the first term, and that the constant term, the end, was negative 2. So it's asking you what are the possible roots of this polynomial that has a leading coefficient of negative 12 and a constant term of negative 2. Well, if you remember from up here, it's p, which is the constant term, over q, which is the leading coefficient. So that means that this one is the constant term, p, and this is the leading coefficient, which is q. So let's look at all the possibilities of p over q. All right. So all the factors of 2 are 1 and 2. All right. all the factors of negative 12 are, let's write them out here. So it could be on the bottom of each of these. Hard to see. Okay, so 1 and 12, right? 2 and 6, 3 and 4. Same thing for this one. 1 and 12, 2 and 6, 3 and 4. Okay, I know that looks weird, so I'm going to write it out so it's a little bit better. So that means, of all the denominators, it could be 1 and 12, 2 and 6, 3 and 4, and the numerator could be 1. Now let's do this one. All the denominators could be 1 and 12, 2 and 6, 3 and 4, and the numerators can be 2. Now, of all of these problems, it's always plus or minus. Okay. Now let's eliminate some of the doubles. So we can eliminate that, because that's 1. Okay. We can eliminate 2/4, which is the same thing as 1/2. Can we eliminate 1/3? Yes, we can. And can we eliminate 1/6? Yes, we can. Okay. So remember, all of these are plus or minus. So let's look at the different choices. So we have, on IXL, the person that got this wrong wrote down that 3/2 is a possible solution. Well, 3 is not a factor of negative 2, so no, it cannot be this one. Now they also answered negative 1/6 is a possible solution. Is that a possible solution? Yes, it is. It's right here. Okay. They wrote down that negative 3 is a possible solution. Is there negative 3 in the numerator here? No, it cannot be. They also wrote that negative 12 is a solution. No, because negative 12, again, is not in the numerator. So this is the answer. So the problem is that you need to write it out. Please stop guessing. Do not do 144 problems. Write it out. Remember, it's always P, which is the constant at the end, over Q, which is the leading coefficient. So this is the constant, and this is the leading coefficient.